And so this is what I'd like to do today. Just remind you that the options that we have with handling errors in the code would be to say we can remember how we said once that if you have method A, method A, right, and it has some executable code and it gets invoked, the local scope of method A, where all of its variables live, is going to be specifically allocated for this method. So when method A calls method B, right, calls method B, which has its own executable code, and this method B gets a scope, get its own local scope where its local variables will be located, and method B calls method C, right, method C of some class, right, there's more executable code, of course it gets its own scope for its local variables, and this is and as they return, the local scopes are removed from memory and we return back to the prior method scope and so forth. One of the mechanisms to pass information from one method to another would be to use a return value. You know that when we execute this code, we can say return, right? So if this method returns an int back to the caller, what happens is that this integer essentially can be, initially if I say return x here, and x is a local variable of my method C, then what happens is that when I say y equals method C, right, if I make this call, what happens that this variable y that lives in the scope of method B will get the value from x, and this is the way to return the value from one method to another. Okay, so we can use the return mechanism. This is the return mechanism. You can say that my methods, this one can return a Boolean type. This method could be a void method, and so forth, right? So we can choose any way we want to which data types to return from our methods, and what return statements supposed to provide those return values that we can return from our methods. And this same mechanism, the return mechanism, can be used for error handling, right? Error handling. I can simply declare that if method C returns -1 as a result, this indicates some kind of error. Or I could say that if method C returns 0, it's an indication of a success. Any other value is a unique code for a specific error. And I can give you a list of errors and even create a set of constants for all possible error codes that method C can return. And your choices may be to have a switch statement that will analyze every possible value in case if it's non-zero, and perhaps generate an error message and do other types of error handling as necessary, right? In method B situation, I can say if I return true, then the result is a success. If I return false, you have to do some extra work to determine what the error condition is, and this may be indicating a problem. Now, method A, right here, method A, could be another, could be programmed to return an object, right? So it could return, it could return back like a gadget, right? So it could, method A could be programmed to return a gadget to the caller, and gadget is a class. And so method A may be like a class factory which actually creates an object right here, right? Creates an object of type gadget in memory, and returns a gadget which is basically an object reference to this object which was created by method A. Okay, so that's another possibility. Here, even with object, I can find a way to report an error through the return mechanism by simply saying, look, if you get an object reference back from me, it's a success. But if you can compare this object reference with null, if I return you a null, I would be indicating that there was a problem associated with this method call, and we could not create this gadget. And this gadget basically, if I return you a null reference, it means that you have to understand that there was some kind of a problem happening here. So in every case, we would say that using a return mechanism to report errors is possible, and it's very typical approach in C programming. But in Java and other object-oriented languages, there is an alternative solution to error handling, which is more universal and has a lot of advantages to the return mechanism. First of all, the return mechanism is limited in terms that you can have a very meaningful method which is supposed to compute some value, and you should return that value back. So the return value is normally, or under most circumstances, has to be used to provide a return value from a method which has the application meaning, not error style meaning. But you're saying, oh wait, wait, that's no longer an option. Now I'm going to reserve the entire return mechanism in my application to error handling. That's good news for error handling, but it's really bad news to what you would normally return from methods if there was no error message. But even this is not the main concern for using return mechanism as error reporting tool. The more important concern is that if method C fails and returns -1, and -1 indicates that this is a problem, you're really forcing method B. There's no other choice for a programmer but to use method B to handle the error. There's no other option. Only method B can detect that method C, which was invoked by method B, failed, and therefore method B has to instantly have an if-else statement of some sort, which would say, okay, what do we do if there was a problem? So this may not actually be very appropriate for method B, because method B may have not enough information to react properly to this problem, right? So this is very significant. If you choose return mechanism to report problems, basically, if you look at, take a look at the C code, different types of applications written in C, you'd be surprised that functions, which are basically methods in C, they're called them functions, right? In every function, almost like 50% of the code in every function, or even more than 50% of a function code, actually has to deal with error handling. Because in non-trivial applications, anytime things can go wrong, and you have to account for that, and it basically overwhelms every method, or methods are called functions in C, and it just like most of the code is error handling code. But you think about, if you think seriously about error handling, errors occur less times than the normal program flow. Most of the time there is no error, but only sometimes there's an error. So it just using return mechanism for error handling creates this imbalance of the code and this unnecessary enforcement to use every method for both practical work and also error handling. So the idea behind the exception is to separate error handling code from the code that deals with normal program flow, right? And so object-oriented languages, typically when we talk about object-oriented environment, you'd say, what do you expect from your object-oriented environment? The answer typically say that we would expect that we can create classes of objects. Classes of objects can have data attributes and methods which describe object behavior. We would probably expect from every object-oriented environment to support interfaces and inheritance, so that we can have superclasses and subclasses. When we have superclasses and subclasses, we can have commonality stored in the superclasses and more customizable pieces in subclasses, and we can of course expect dynamic polymorphism work to be available to us, so that we can override methods. So more specific methods override generic methods. This is something that we did today with toString method inside of our enumeration. And so this is what you would typically expect. You can, in this line of expectations for object-oriented environment, you would also perhaps say, I'm also expecting normal encapsulation rules to be available. Public, private, protected, all kinds of encapsulation tools to control the visibility, the scope of and visibility of your variables and methods, and therefore manage your interfaces and public interface versus implementation and all of that. And finally, in today's world, you should probably say that I'm also expecting an object-oriented programming language or a set of object-oriented programming features to support exceptions, because exceptions is an object-oriented approach to handle errors. And so obviously next time when we get together, we will do a formal coverage of this topic, and we'll do this discussion. So I hope everybody has a great spring break. We will continue discussing our homeworks on Thursday. If I don't see you on Thursday, enjoy your spring break, and I'll see you guys in 2 weeks or next Thursday. Okay? So if you have any questions or concerns, send me your email. Otherwise, we will proceed with this specific plan. So thank you very much.